So changed my setup a little bit so I can face you better. Okay. All right, inequalities and word problems. Okay. When given a word problem, you'll have to read and interpret the question in order to what? Produce the appropriate inequality or inequalities. Right? So you're going to have to be very careful there. Things to keep in mind as we... so what does an inequality do, folks? What does it really do? An inequality essentially provides a restriction to a possible set of answers to a question. So it kind of says you can't take everything. You have to kind of restrict it to this pane, right? Either above or below the line. Things to keep in mind when you're working with word problems. Type of data. We can have discrete or we can have continuous. Okay, so discrete in a nutshell, things you can count. Okay, things you can count. So examples for that would be number of coins, people, number of cans when you're painting a room, etc. Okay, things you can count. And another way is they only exist in whole quantities. So for example, how's that going to affect? Okay, when you have discrete data and you find the corner points, I'm going to make this nice and big, you have to round POIs. Okay, make sure this is nice and big and it stands out. So if you use your calculator and you find that the corner point is this, okay, we will round to 7, 8. So if I ever ask you a question, right, and you know that X and Y are discrete data, then this is wrong. You have to state it like that, okay? So I'm going to box this in so it stands out there. Continuous data, don't round the POIs, okay? And I think of continuous data as things you can measure. Things you can measure. And that would be area, volume, length, etc. Don't round. So if it's continuous, don't round. If it's discrete, round. And I don't know, I'm going to cut this, like I'm going to make sure we don't mix this up. So this belongs to the continuous, discrete, sorry, this belongs to continuous. That's it. So it will happen from time to time. Okay, next, the next thing you need to be aware of is almost all cases involve data that can not be negative. And I can go ahead and tell you, all of our cases, that's going to be the case. Okay, that we're only in the positive quadrant, in quadrant 1. Okay, so therefore, different color for this one, you will be restricted, right? The graph will be restricted to quadrant 1. And watch this. This is new. Therefore, we state the implicit constraint saying that X and Y have to be greater than or equal to 0. Okay. Values cannot be negative. if I ever ask you for the implicit constraint, like the implicit restriction, implicit means it's not out in the open, it's kind of like implied, like we're just assuming that, okay? Then you need to make sure you state this little statement right there, okay? X comma y is greater than or equal to 0. Okay. And so watch this, no context versus context. Okay. So if you have no context, all 4 quadrants, right? All 4 quadrants. I'm just going to say Q's. Okay. If there's a context, only quadrant 1. Okay, when there's a context. And so watch this. I'm going to use a red pen for this to make sure. If you have all 4 quadrants here, and keep in mind there should be arrowheads here because it just keeps on going. And there's the x-axis and the y-axis. Okay. I leave those out purposely so that we can talk about that again and again, right? We review the fact that everything should be labeled. There's only one POI here. Okay. And I'm just going to say only one. Only one POI. That's actually 12,9, by the way. I'm just gonna tell you that point right there. Point of intersection is 12,9, and this would be the solution region. We're assuming that because it's a system, we use reverse shading, and that means that whatever isn't shaded is the solution to the system. Okay. Context. So if you were to take this exact same question and just focus in on quadrant 1. Okay, look up carefully here. If we just take quadrant 1 and copy this over, this is what's going to happen. Watch. So we're going to say it goes through 25, so something like that. So just make a dot right there, this line, and it goes through 20, 0. So let's go and make a dot at 20, 0. Grab a ruler, or if you don't have one, try your best to. So this would be the one line that is solid. We do not go outside into the negatives here, and we also don't go to the negatives down here. You're restricted within quadrant 1. And then the dashed line, let's try our best. The dashed line goes, the y-intercept is just one box above 10. So just make a dot right there. And then it goes through 40, 0, right? So it's going to go through here at 40, 0. So these are the two that we're going to connect for the dashed line. And we're going to shade out everything. What's the solution right now? I'm going to let you first copy this because I need you to pay attention to the next part here. So your solution earlier, if there had been no context, would have been all of this, and it actually goes to infinity here. But right now, we're just going to take this wedge here. If you look up, right, this is my solution region right here, this part right here. It's restricted. The x-axis is kind of like the bottom boundary here. So I'm going to shade out all the other parts. So I'm going to go to the dashed line and shade that all out. Okay, and we're also going to shade out everything below the solid line, but make sure you stay within first quadrant. So it's a little challenging in that sense, right? Again, coloring between the lines comes in handy here, that skill, right? So this is what the graph is from now on. We're going to be restricted. So we go here and we call this X, we call this Y, but this could be, watch here, where the X-axis, this could be coins, cans, etc. Okay, I don't know if you're getting that part. Let me zoom into just that part. This could be, this is going to be a word problem, right? So it could be money, you name it. And the Y could also be coins, cans, etc. If you don't mind, I'm going to use a red pen here, but the Y and the X-axis are boundary lines, are exclamation mark. Okay, so you make an arrow to the X-axis and an arrow to the Y-axis. So there should be no line going into those. There should also be no shading going into those areas. We're sticking to quadrant 1. That's how things are going to be different. And watch this, the POIs. We still know that this is, there you go, I'm reviving it, 12.9. This is still 12.9. It hasn't changed. So that is my POI here. I'm going to write them down. 12.9 is still one of the POIs, but there's two more now. There's this one here, right? 20.0. So I'm going to go 20.0. I'm going to label that on the, and this one here, which is 40.0. So now when you do word problems, the intercepts are possible POIs, points of intersection. Whereas before, what was the only POI that we had? The point of intersection would have just been 12.9. Okay. But all of a sudden with the word problem, you've got the x-intercepts in this case. It could have been y-intercepts, okay? It depends on where your solution region is. So you're going to have to watch out for that. Okay. But before we graph, the most challenging part is coming up with our inequalities. That is going to be what we're going to focus on today. So let's go to 42. And this requires you to make sure you have certain hints on your study sheet. Right? What are some key words? I'm going to use a different highlighter for that one actually. The key words would be if you see up to, a maximum of, no more than, has a capacity of, at most, right? Or at least, or a minimum of. All of those are key words that indicate inequalities. And I just added this before, so, or a little while ago. So I'm going to say this. Yeah, I'm going to give you a little cheat code here. See page 48 for. Let's just call it for what it is. Cheat code. Okay, so we're going to go to 48 to just clarify this a little bit. It's going to help you to know for sure which way is my inequality going to face, because that is always a bit of a challenge. So 48 should be a blank one, and then we're going to go back and actually rewrite our. So keywords to write inequalities. I'm just going to call it that. Keywords to write inequalities. If you have something that says up to or at most, a maximum of, capacity, holds up to, no more than, if you have anything that is like this as well, because I'm not guaranteeing you that I'm covering all the words, but this is enough for you to kind of wrap your head around it. You will immediately, you should be thinking of your inequality will go this way. Versus, on the other side, if you have at least, minimum of, no less than, at minimum, then you should be thinking of this symbol. Let me give you a quick example under each of these. So you have your cheat and then you have an example right away. You must sleep. No, I'm going to use that one on the other side. Sorry, my bad. You earn up to $1,000. You earn up to $1,000. If Y represents your earnings, right? Then what this statement is saying is that Y is less than or equal to 1,000. Because if somebody says, hey, you earn up to $1,000 working at Circle K, that means that whatever your wages would be for that week, you could make 900, you could make 800, 700, anything that's less than or equal to 1,000. You could actually make exactly $1,000. You would still, the statement would still be true. So that would be the inequality, right? So the words translate to this inequality. I'm going to use this sleep example here. You must sleep at least 7 hours per day. Okay, so let's let sleep be X. X represents the number of hours that you slept. If it says at least, then if this represents the number of hours you slept, then that has to be greater than or equal to 7. That would be the statement that you would want to write to have that jive. So if you slept 8 hours, you're fine. 9, 10, 11, 12, 13, right? You can actually sleep exactly 7, but if you sleep less than 7, this statement would be false. Okay, so that's what you're doing there. So let's go back to 42 now. If you've copied this, I hope you have this. I would say have this on your study sheet. It's going to help you big time, because then you know which way this is pointing. Some students struggle with which way does it point? Which way is my inequality supposed to face? And so this hopefully is going to take that away from the guesswork. Write an inequality for the following statements. Go ahead. let X be the number of people. So I'm going to use two different highlighters here. X will be the number of people, and Y represents the number of pets. Okay, sure, probably use green for that one. Well, that's okay. So I want you to, we're going to write a few out, and I'm going to kind of let you do a few yourselves. Okay? Maybe I'll tell you this. Variations, you could have Y is greater than or equal to a number. You could have X is less than or equal to a number. You could have X plus Y is less than or equal a number. So these are the variations. Don't worry so much about which way it's facing. Okay? Listen carefully. That's not what I'm saying here. I'm just saying that you could have just a Y, just an X, or you could have a combination of X and Y. So have your variations there so you kind of know what to expect. So let's write some, okay? Pay attention to this one. A building can accommodate no more than 400 people. This is an inequality right there. And 400 people is our number, obviously. Okay? First thing I want you to think of is X represents the number of people. We have people here. So we definitely have to use the variable X. It's only talking about people, no pets, right? Okay. So we would start with X. If it says no more than 400, which way should it be pointing? You can look at your cheat on 48. It's this way, right? No more than 400 people. So the number of people has to be less than or equal to 400. That's how you would write this inequality. Okay. Let's do another one. A dog park can hold up to 45 dogs. In this case, you're talking about just dogs. Those are pets, right? So we would use the variable Y to get us started. Can hold up to, that's my inequality right there. So you have to maybe go to your cheat. And so what would you say? Y is less than or equal to 45. Okay. That's your inequality there. Next one, a dog park can have up to 100 dogs and owners combined. So you've got dogs and owners, those would be people, combined. And there's the word combined. So here you have both variables at play. So X plus Y. Okay? That combination, right? It says that can have up to 100 dogs and owners combined. So the combination of these two has to be less than or equal to 100. That's how you would write it. Okay. All right, I'm going to pause here for a bit. I know you're scared right now. You're like, I don't know what's going on. All I want you to do is try to write me out something here. An inequality that you think translates, right? That translates this statement. You write an inequality. Don't worry about getting it wrong right now. There's lots of space. We can just cross it out and do the next one right beside it, okay? Try it out. So all of the ones that remain, and if you want to try that example with the numbers, you can try that as well. So a couple minutes, give it a try. Look at your cheat on 48. A vet can see up to 24 pets per day. So we're talking pets, so that should be Y is less than or equal to 24. Okay, so the number of pets has to be less than or equal to 24. You cannot have more. The doctor cannot see more. The vet cannot see more than that. A committee needs at least 5 members. So we're assuming people. So people has to be which way? that number of people has to be greater than or equal to 5. So you're flipping it, right? The at least tells you that. The up to, in this case, tells you. So it's the keywords that tell you which way to face. Okay. A stadium allows up to 20,000 visitors and pets combined. So I'm thinking of, what's that dog whisperer's name again? Cesar Millan. Have you ever seen the dog whisperer? Anyways, so he fills up stadiums and you can bring your dog to watch him train other dogs. So anyways, that's what I was thinking when I wrote this. So visitors and pets, so you want to combine them like this. And so this number has to be less than or equal to 20,000. And let me say another keyword here that could have been used here. Stadium, write this down. Stadium has a capacity of 20,000 visitors. So it means that you can have up to 20,000 in that place. You don't have to fill it up exactly, right? You don't have to have 20,000. It just says that, hey, you could have up to that much. Next, I don't know if you tried this one. Two numbers have a sum that is less than 20. Okay, let's let x be first number and let y be the second number. So we're saying that the two numbers have a sum, so x plus y, this is less than 20, correct? You would write it like this. Not less than or equal to, less than 20. And then it's another statement. Twice the first number plus 5 times the second number is at least 50. So just say do exactly what it tells you here. Twice the first number plus 5 times the second number is at least, so it's greater than or equal to 50. Okay, so this is IQ number 2, and this is IQ number 1. Okay, so you've got two inequalities which you could technically graph now if I asked you to do it. Note, this is not a word problem. This would be all 4 quadrants, right? This would span all 4 quadrants. This would span all 4 quadrants. Whereas, make sure you write this part down. If we go up to the top, those were all like non-negative values, right? You could not use negatives for the tops here. So watch what I'm going to do. I'm going to use a red pen and let you see this part. All of these scenarios have the implicit constraint. The implicit restriction of, watch this, the fact that x and y have to be greater than or equal to 0. All of them. That was just something that I didn't even have to tell you. But if I ask you to state it, this is all you need to do. X comma y are greater than or equal to 0. All right. I'm going to ask you to go to 44 here. So normally I jump into an example and I solve it. But I'm going to ask you to do this. Okay? I'm going to walk around and help you out if you're stuck. 44. Writing inequalities from word problems. And I'll get you started. I want to be a bit more specific here. Write the inequality for the following scenarios. Make sure you define the variables. Okay? I did that earlier. I told you what x and what y represented. So let's say this. A fridge displayed can hold up to 900 centimeters cube of stuff. So what you do is you let X be the space available, right? Or the fridge capacity. $44. You let X be the fridge capacity, and in this case, it's centimeters cubed. Is this discrete or continuous data if it's like this? It's continuous. You can measure volume, right? It could be a decimal, not a problem at all. So all you would have to do is this. X is less than or equal to 900. That's all you have to do here. So you first define your variable. You could have used y if you wanted to. You could have used any letter of your choice. I usually stick with x and y. And once you've defined it, you go and place it in here. Let's try one more. In order for the university to offer a Spanish course, it needs at least 12 students registered for it. So what I'm going to do here is I'm going to let y be number of students. So it actually gives it away. What is this? What kind of data is this? It's discrete. So let's just make an observation. Right now it's not super important to state that, but I think I want you to start noticing that. So if I chose y, you could have done whatever you want. Y is, which way is it pointing? Which way is it opening? You want at least 12. So the number of students, you want it greater than or equal to 12, like that. So sometimes it's x and y, sometimes it's just x, sometimes it's just y. So remember that. Okay. So give this a try. See how that goes. Write an inequality for all of them. It's the hardest part, I know, but I'm going to give you a hand, okay? So go try that before I do my graphing part, before I do the solving part. Try to write an inequality for every single scenario, okay? Same with the spend, so 45, 44, all the way to 45. That's what I'm going to ask you to do right now. Page 44 to 45. So I'll give you a few minutes to get started, and then I'll come by and check on you, all right? In a good way. I just want to make sure you're doing okay. So thanks for trying, guys. That's all I can ask. So in this case, you have potatoes and sunflowers. So yeah, you got to let x be the number of potatoes, and y would be, oh no, sorry. It's just the weight. Weight, sorry. If you just said potatoes for now, I'm fine with that. Weight of potatoes, and y is the weight of sunflowers. So x plus y, their combined weight, if you read this carefully, has to be greater than or equal to 1,500. So if it's 1,500 exactly, you start profiting. So more is better, okay? So a daycare takes care of toddlers and preschool children. So x would be the number of toddlers. Y would be the number of preschool kids, right? And so based on staffing, it can accept up to 50 children combined. So we're just going to go like this, and that combination has to be less than or equal to 50. So you can have up to 50 if it worked out for you. Let me get you started on this one, just the first couple, and then I'm going to say 44 and 45 as homework, okay, to try that yourself. So this is now getting a little bit more, pay attention, it's a system. So we're going to have one scenario, and there's going to be a bunch of inequalities resulting from it, okay? So Spence is a DJ is often hired to play at birthdays and weddings. Okay, so I don't know if you catch that, but that usually tells you what your variables are. Okay, so I'll say let X be number of birthday parties, and Y would be the number of weddings. Okay, if you think about it, is this discrete or continuous data? If you just look at what X and Y are, it's discrete, right? You can count the number of birthdays, you can count the number of weddings. So I'll just make sure I already start thinking about it, that this is discrete. Let's go back to the question now. A birthday event usually takes about 3 hours, while a wedding takes 5 hours at a time, including setup and cleanup. He earns a flat fee of $450 for every birthday and $625 for every wedding. So lots of information here. Okay, here are the restrictions now. Spence has at most 40 hours per week available. Okay, let's just focus on the at most 40 hours. Which way will your inequality be facing? Which way will it, where's the pointy end? Like this, right? Like this. Would you agree? Did you look at your cheat? Okay, this is 40. That's, you know that the tail end is going to be that. Here's how things are going to be different. You look at the 3 hours for every birthday and 5 hours for every wedding, correct? So now you're going to start having coefficients in front of your variables. So it's going to be 3 hours for every birthday and 5 hours for every wedding, right? Because you're going to, and these X and Y represent the number of events, right? So this is how things are going to change now. 3x and 5y is less than or equal to 40. So watch this. If you did one birthday party and one wedding, how many hours will you have spent that week? 1 and 1. That's 3 and 5, 8 hours, correct? So you still have more parties to go to or more events to host, okay? Spence would like to earn at least $2,300 per week. So I will focus on this part here first and foremost. At least $2,300. Okay? What is going to come on the left? How much do you earn for every birthday party? $450. So right now we're talking about money, and we know how much we make for every birthday party, and we know how much we make for every wedding. So there you go. This has to do with the hours. This has to do with the money. Okay? So there's a restriction on the time. There's a restriction on your money coming in. Okay? Spence would like to DJ at most 9 events combined per week. At most 9. So would we agree that this is what goes on the end there? If you get this right, you're almost there. What goes on this side? X and Y. Because those are my events. So it's just talking about the events. Okay? Number of events. So this is a restriction on the events. This is on the money. This is on the time. What about this one here? He would like to DJ a minimum of 2 weddings per week. A minimum of 2 means it's like that, correct? And we're talking weddings only. So what variable would you use? Y only. Only weddings, right? Only weddings. And so it's not talking about combined, it's just talking about weddings specifically. So it's just a Y. Define your variables, then write the inequality for all the restrictions. We already did that. Right? So here, take that, Mr. Durson. Right? We already did that. That's usually what you're going to start with. Okay. All right. So page 45 is homework because I did 44. So you're welcome. Let's go to 43. I know you just want to write that, but you're going to be done in no time. And then, right, I need you to have one already where you start graphing these things. This is ultimately going to result in a graph. Okay? That's where we're headed. So let's go to 43. And if we run out of time, I will finish the video. You walk out, I finish the video. So your homework will be also to make sure you get the notes down if we run out of time. Okay? It's because this is the last unit and we need to make sure we get to the end of it. Steps to interpret the graph and solve the word problem. So this is like the whole shebang, okay? This is everything. I usually guide you through this, so you don't have to worry about the steps too much. Introduce the variables. So what are my variables? What's x and y going to be? Number 2, state the implicit constraint or restriction. That's just this fella right here. That's the implicit restriction. It's always the same. It's like the domain of a parabola without a context. X belongs to all real numbers. That's the same thing. Write the inequalities presented by the question. Each restriction should be represented by an inequality. Graph all the inequalities in step 3. State the POIs, just like you've done before. State a possible solution found in the solution region. Let's do this here. A certain manufacturer makes scarves and toques. It takes 50 minutes to make a scarf, 10 minutes to produce a toque. The company has up to 2 hours of production time available. Okay? Graph the solution set, state the POIs, and give us a possible solution. So let's go through the steps. Let X be the number of scarves. Let Y be the number of toques. This is what kind of data? Discrete. The number of should give it away. Okay? This is discrete data. What does that ultimately mean, folks? The only thing that this will tell us is our POI will be rounded. That's basically it. That's why I make a note right away. What's the implicit? Constraint. What's the implicit restriction? Oh, what's wrong with this? Yeah, that's a common mistake though. Students think I won't catch it. I do catch it. It doesn't matter which way it's opening. So this is kind of like, let's get this out of the way and now we can solve. Watch this, the first bullet. It takes 15 minutes to produce a scarf, 10 minutes to produce a toque. Is there any hint of an inequality in that statement? Does it say up to, must make a minimum of? No, it's just facts, right? Next statement, the company has up to 2 hours of production time available. This is your inequality. How did I know? The keywords. Yeah. That is a giveaway for inequality. So here it is, inequality. There's only one on this one. So what I will say is, it has to do with time, correct? So we have some information about the time. So 15 minutes for every scarf that I produce. And every toque takes 10 minutes. This is going to be less than or equal to, can I say 2? No. I cannot say 2 because the time that it takes to produce is given in minutes. My restriction is in hours, no big deal. That's 120 minutes, correct? That's all. Just watch out. This is 2 hours. In minutes, obviously. That's it. That's the inequality. Remember when I gave you inequalities? You want to graph them? What's the first thing you should do? X, Y intercepts. Just make sure you write this down, okay? You can look at this. 15x is equal to 120. divide both sides by 15. X is equal to 8. So 8, 0. Because now we're graphing it. There's only one inequality, okay? Next is 10y is equal to 120. Y is equal to 10, 0, 10. What else do I do normally? I rewrite this, correct? I will do that as well. Let's rewrite it. Watch what I do. To save space, I take the inequality, I bring the 15 over to the other side already, subtracting. And plus 120, right? So the 15 comes over subtracting. Then I divide everything by 10. I don't divide by a negative, correct? So I don't have to worry about flipping. In fact, did I make a mistake earlier? Anybody catch this one? 120 divided by 10? I should have caught it, but you know how I caught it for sure is here. When I went 120 divided by 10, that's 12, and I checked. That was a 10 up there. Can't be, right? It has to jive. Okay, so what do we know? This is going to be a solid line. True region is where? If it's less than, true region is below the line. I'm going to shade where? I'm going to shade above. I'm using reverse shading. I'm going to circle that part. And now I'm going to graph this. A straight edge makes this a lot easier. What goes on the x-axis? Number of scars, number of toques. What kind of scaling do I need? I only have one inequality, right? The boundary line is 8, 0, 0, 12. So watch what I'm going to do. I'm going to go 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. I'm going to label every other one. I'll use the same scale for my y-axis. 2, 4, 6, 8, 10, 12. We're almost done. Plot your points. 8, 0 is right here. 0, 12 is right there. It's going to be a solid line. I label it right away. 15x plus 10y is less than or equal to 120. Where am I shading? Above the line, correct? Right here. I'm using reverse. In fact, I use reversed almost every time. I started you off with regular, and then I switched over. I will ask you to go, so basically page 45 to 46. 46 has a little bit of graphing there. So you basically set up your inequality and you graph just with one inequality. I don't need you to do every single one with a graph, but at least write out your inequality and check the key against it, okay? Question before you go. What's a possible solution? Anything in the white zone here. So could you make 2 scars and 4 toques? Right, so anything in here would work. Could you make 8 and 0? 8, 0? Yes. You could make 8 scarves and no toques, because this is a solid line. Anything on the line is also acceptable. Thank you guys.